Example number 2, we want to differentiate the two functions. The first one, f of x equal to 1 over x squared. Using the algebra we learned before, we can write 1 over x squared as x to the negative 2. So the first derivative of f of x, we use the power rule. So the negative 2 move down, and the exponent of the x decrease 1, so that means minus 1. Then we have negative 2 x to the negative 3. Or if you want to write the number exponent in the positive way, so you do negative 2 over x to the third power. Problem B, we also learned in algebra that we have x 2 over 3. So the formula is, if we have n x to the m, then x to the m divided by n. So again, we take the first derivative of this function, we will use the power rule. Then 2 over 3 move to the front of the x, and then the exponent of the x decrease 1 unit. So 2 over 3 times x. So we're going to find the least common denominator is 3. Then we get negative 1/3. If we want the exponent to be positive, we're going to let x move down. Or you can write 2 over 3 cube root of x. Example number 3, we want to find the equation of the tangent line and normal line to the curve y equal x square root of x at the point 1, 1. So the function y equal x square root of x, this is the same thing as x times x to the 1/2. Then we can add the exponent. So 1 plus 1/2, because we have the product rule. So we will get 3 over 2. We will take the first derivative of this function. So 3 over 2 moving down, and the exponent 3 over 2 minus 1. Then 3 over 2 exponent 1/2. Okay, so this is the first derivative, but we know that the first derivative is the slope of the tangent line. So at the point 1, 1, that means x equal to 1. Then the first derivative at x equal to 1 is, which is the slope of the tangent line, is 3 over 2 times 1 to the 1/2. And we got the answer is 3 over 2. So we explain this one is the slope of the tangent line. Now we use the equation of the line y minus y1 equal m x minus x1. So y minus 1, because we got the point is 1, 1. The slope is 3 over 2 x minus 1. So we will distribute 3 over 2 and then add 1 both sides. The LCD is 2, so we got 2, and then we got minus 1/2. So this is the tangent line. Equation of the tangent line. What is the normal line? The problem asks us to find the equation of the normal line. Normal line is the line that perpendicular to the tangent line. So the equation is y minus y1 equal m parenthesis x minus x1. And we will use the slope of the normal line is reciprocal, opposite of the reciprocal. And also, the normal light also passing through the point 1, 1. So the slope of the tangent line is 3/2, then opposite, which is negative, and reciprocal. Then parenthesis x minus 1. Now we distribute this and then add 1 both sides. The LCD is 3, so we got 5/3. So this one is the normal line. The question asks us to wrap all of them. So we will first wrap the curve first. So I will make the table for this. So x and then y equal x square root of x. If I make x equal to 0, I got the y part is 0. If I make x equal to 1, the y is 1. If x equal to 2, then we got 2 square root of 2. So 2 times 1.4 is 2.8. And then 3, so we have 3 square root of 3. So 3 times 1.7 is 5.1. So we have 2 on x and 2.8 on y, 3 on x, and 5.1 on y. Now we have the curve like this, right? Notice that the domain of this function is all positive number, including the 0, but not negative. Now we will wrap the tangent line. So if the point, if we have x equal to 0, so let's make the tangent line. So you have x and you have y equal 3/2x minus 1/2. So if x equal to 0, then we will get negative 1/2 for y. And then if x equal to 1, then we got 3/2 times 1 minus 1/2, and it's equal to 2/2, which is 1. And we know that the point 1, 1 is on this tangent line. And if you want, you can make one more point, right? So if we make like 2, then 3/2 times 2 minus 1/2 is 6/2 minus 1/2 is 5/2. 5/2 is 1 is 2.5. So 2, 2.5. So we got the tangent line in the green color. Now the normal line. So we have normal line. The equation is y equal -2/3x plus 5/3. So if x equal to 1, the answer will be 3/3, which is 1. And if x equal to 2, then -2/3 times 2 plus 5/3. So that's going to give us -4/3 plus 5/3 is 1/3. 1/3 is like 0.33. So 2, 0.33. And then we connect these 2 points and extend. So what do we see is that the normal line and the tangent line perpendicular of each other, right? and also the normal line perpendicular to the curve at the point 1, 1.